You just need to change the conclusion. If you make a critical error in the discussion section, it's also not so horrible. You need to change the discussion, and maybe it affects 1 or 2 small points in your conclusion. But imagine you make an error in the methods, or even worse, in the introduction, then you need to change all the subsequent chapters because they are all built on the preceding chapter. So especially the first 2 chapters are very important, I think, in particular when we're talking about methodology. And in these first chapters, we will find critical phases of error where it's really worth to pay attention to what we are doing and make sure we are doing it in a good way. The first one, and in my opinion is the most critical one, is what I already talked about, is defining the right research questions and goals for your research. The second one and the third one belong to the method section. The second one is developing the study design in a meaningful way. That includes basically everything: the sample you choose, the protocols you implement, the devices you use for your measurements, and eventually also the statistics that you apply. The third critical error is specifying data progressing. That means something like smoothing data or filtering data, for example. Why are these 3 in particular so important, in my opinion, is, first of all, as I said, if you define inappropriate questions, all the methods you do, what you actually investigate, may be meaningless. So that's, I think, quite understandable why this is so important. The second one, all the study design, all these detailed information about sample, protocol, devices, variables, calculations, statistics, and so on, they define what you actually do. So if something that you do is not following a recommended practice or not scientific standards, then of course all the results you achieve are meaningless because you should have done it in a different way. And someone could criticize it or identify it when reading your thesis or article. So that's really important to make sure that the plan you have for your study design and for your implementation, that this plan is solid and approved by someone else who also has a good idea or good expertise. The third part, specifying data processing in particular, is important because once you collected your data, once you followed your implementation plan that you described in the methods, very often, depending on the type of data and depending on the field you're active in, you do something with your data before analyzing it. So for example, I do a lot of studies in biomechanics, and very commonly in biomechanics, we filter or smoothen some data because there is artificial noise in the data that we want to remove. And there are guidelines for how to filter data. So you should know these guidelines. You should know the literature about how to filter specific data. For each type of data, it can be different. Why this is so critical? Because if you move on and you process your data incorrectly, then you can run your t-tests, ANOVAs, all the statistical stuff you want. You can get results and so on. But if the data is processed incorrectly and someone asks you, like your supervisor, asks you to do it again in a different way, all your results may be different. You run the same t-test, but you get different results because the data is different. So if all the results is different, maybe your discussion must be adjusted, must be different. That means also your conclusions are affected. So these 3 things, very important, I think. So what should you do? Especially before entering a new phase. So being at these timelines or these milestones of critical errors, especially at these times, what you think you should do, I think, is to check what is available in the literature about your topic, your goal, or your planned methods. So use the knowledge that was created by others before and was documented in the literature, and try to find the best way how to do your study based on other references. Pay especially attention for critics. There are studies and articles that specifically investigated certain methods of how to do something. And they studied, well, the one method may be better, more precise, more accurate, whatever, better in a certain way than another method. So these kind of critics are quite interesting and is a good recommendation for you to, first of all, to choose for your own, but also to justify in front of others when your supervisor is asking you, why did you follow this method? And you know, oh, well, because there was research criticizing the other method. It's a very good reasoning why you choose this method. So critics on specific methods. You can, of course, compare in the literature what others have done. This is like common practices. You collect information about common practices. This is a good addition, and you should always do this, but don't finish your search there. If you just copy what others have done, maybe you copy a bad practice. So it's always good to know what the majority of other research was doing, but don't follow it blindly, because it may be that for 5 years or for 10 years, researchers have implemented certain methods. That was the common practice, and that was good. But then after 10 years, someone found out there is a problem with this method, and he developed a new method to make it better. Then after this publication, new research should apply the new method. So if you come after this publication and you still use the old method, it doesn't matter that until then everyone was doing it in a certain way. It is now known that this way is not so good. So you should do it in the now known better way. So this is what it means to identify the best practice in the literature. Consulting the literature, see what kind of knowledge is there about different methods, and choosing the best one. To be sure that you chose the best approaches, you can ask your peers, your colleagues, your tutor, or your supervisor before you take the next step. So when you are at this point where you define the research question, before you start collecting data, ask someone to approve that what you have done so far is meaningful and correct, that the questions are good. When you set up your plan, your methods, before you implement them, ask your supervisor, your peers, your co-authors, and so on, if they agree, if they think it makes sense, and so on. Before you analyze the data that you processed, ask if the processing was meaningful, correct, and so on. I added at the bottom of the slide these 4 words: ask, not only report. I added this because these recommendations only work if you are honest with your supervisor, if you ask how to do the stuff. If you just report what you have done, especially if you are not very honest with what you report and you just show the good results, the successful things, and you hide the negative or problematic things, then your supervisor, based on the limited information he or she receives, may not realize that you did something wrong, or that you may cause in the future something problematic or bad quality, simply. So it's not only, I experience this quite often in Taiwan, maybe it's a cultural thing. So don't only report the good things to show you're a good student, be brave to ask if this was done in a good way. That is part of the learning process and helps enormously in achieving good quality result in the end. So how to move on after having defined our research questions? Two things basically I want to recommend. Plan the entire method section, the entire methodology of your research before doing something. Don't start data collection before knowing exactly what you will do with the data. Before you do data collection, you can write all the method section, except for the statistical part, maybe that depends on how the data looks like. So maybe if the data is normal distributed or not normal distributed, you need to choose a different test. But that's it. Everything else you can write before going into the lab. And that's a very good advice, in my opinion, to make the plan entirely before doing it. Not expanding the plan or making the plan in a further development on the flight while you're collecting data and so on. And the second part, look for approval of your plan. So ask your supervisors, ask your co-authors, and so on. That means first plan and then implement the plan, not kind of a mixed thing. So what do you have to include in this plan, in the methods? And what makes methods good? So how to get good methods, good methodology. In general, the answers are very straightforward and simple, but maybe hard in practice to realize. What should you include in the plan, in the method section? Basically, you should include all information in a detailed enough manner to allow for replication of your study by someone external who only reads your methods section. He is not involved in all the process before. He doesn't know you, or she is not a colleague of you. Someone external, like if you talk to me, we have never spoken with each other before. You send me your method section, I should be able to replicate the same study. So you need to include all the information that is necessary for replication of the study. Simple as that. I know in practice, it's not so simple because sometimes you forget something, or sometimes you add something that is actually not so important for the replication. You can replicate it and a detailed information may have no impact, no effect. So how you can test this for yourself is that if you write something or you decide some information should be included in the methods, ask yourself the question, is this information relevant, necessary for someone else to replicate the study? If yes, it must be included in the methods. If not, remove it. It's not important then. The other thing is not the question what to include, but how to make it good. How are the methods good? And this is a concept that is also, I summarized it in one sentence, but it's really hard to maybe even to understand and even more to implement it in reality. Good methodology, good methods are if you will only have one reasonable explanation of the results you achieved that can explain and give the answer for your research question. So the goal of your research is always to answer the questions that you defined in the end of an introduction, right? In the end of the introduction, you had open research questions. So everything you do later on serves the purpose of answering these questions. Now, the results I achieved because of the methods I chose should help me to explain and to answer my question. In reality, I may very often find many different explanations for an observation. The results are my observation. This is what I observed in the data. And now in the discussion section, I try to explain my results. I make interpretations. I think about what does this mean? How can I explain what I observe in the results? And this explanation should be solely answering my research question. That's the main goal. The problem is if there can be other explanations that can also explain the observation, the results. Then I don't know which explanation is correct. Do I observe the result because of the one explanation that I was interested in? Or is the other explanation correct? This is basically the quality criteria of good methods, allowing only one explanation of the observations, and this explanation should be the one that is answering my research questions. I want to give you an example to maybe understand this in a little bit easier. If you collect data, let's say you collect sprint performance from a sample, and they come 2 times to the lab because you want to know if they perform better before and after a training intervention. So they come the first time, you measure the sprint performance, then you do 6 weeks intervention, some sort of training, and then they come again for a second time to the lab or to your sprinting track, you measure sprinting performance again, and you compare if the sprint performance changed between the first time and the second time. A classic longitudinal study design of an intervention. Well, there may be many factors that influence the sprinting performance. One factor is the intervention. All the other factors, you need to control them. Otherwise, they may explain the observed differences. So if you don't control whether the athletes did another training also, you don't know if this was the reason for the different results. If you don't control if they slept well, you don't know. Maybe the difference in sprinting performance is because they had different sleeping patterns sometimes for some reason. Or maybe they had stress in work in the first 6 weeks, but not in the second 6 weeks because they are all project workers, something like this. You don't know. Is it because of the intervention or because they had different working conditions and stress? Or nutrition, or they had a big party before the lab and they show up all drunk. You don't know. So many factors in reality, and you need to try to eliminate them or at least control for them, because otherwise each other factor may be an explanation for the difference you observe for your results. So that is the idea, that you build methods in a way that in the end only one explanation is reasonable for this difference you observed. And this explanation is answering the research question. This is it about methods. So this is everything that is important for methods. So can finish now here. That's everything you need to know. In fact, this is really the key idea of what you need and what makes it good. In more detail, of course, we can go through single subchapters, typical subchapters of methods. The methods section describes everything you do, the entire methodology of your study. So again, this is a typical structure of subchapters for the method section. It depends, of course, on the methods you choose. Sometimes you don't have information about all these subchapters, but very typically you have some sort of sample, some sort of human participants very often in sports science, and you need to describe this sample, the participants. So you need to describe how many you took, who are they, like the characteristics, how did you select them? Sometimes it's relevant how you selected them, sometimes it's not. What were inclusion, exclusion criteria, and so on. The next subchapter very often describes the overall study design. what you did in the study, or what kind of experiments you were running, or did you implement an intervention? What kind of protocols did you use? So this is basically what was done and how it was done. Then another subchapter includes characteristics of the devices or instruments or tools that you used. This can be technical equipment like force plates, Vicon cameras, IMU, and so on. This can also be in other studies a tool like a questionnaire or a survey. So what is required here is to specifically define the devices, the tools that you used, what kind they are, what models, company, if they were validated or not, and what kind of settings you used. All these things affect the measurement accuracy, and so the data. So these are important. Then I already mentioned as a critical stage of error, processing. So another subchapter can be how you process the data. What did you actually do with the data once you collected it? That means processing, that means calculations, and what variables basically you defined, even before running calculations. So this is everything how you handled the data. Also quite important. And then at the last stage, statistics or ways of analysis. It can be different ways, but very often it's statistics, very often it's inferential statistics. So you need to define what software you used, what kind of tests you chose, and also don't forget the definition of benchmarks. Benchmark, you know, probably for significance level is like p-value being below 5% or below 0.05. But there are also other statistical values or properties having benchmarks, and these are very typically effect sizes, also very important. Eta square, Cohen's d, all these things, they also have benchmarks that define what is a strong correlation, what is a moderate correlation, what is a weak correlation, and so on. So these things must be defined. Let's go through all these subchapters in a little bit detail. First, starting with the participants. Maybe two relevant and often asked questions are, how do you derive a suitable number of participants? And in other words, what is the necessary sample size? There is a statistical approach to it, which is to run statistical power analysis with software like G-Power, or there are websites to do it. And the software, if you enter the information that you require for your research, will tell you how big your sample must be, considering a certain statistical test that you want to implement. That is the one thing, that is a good practice, and that is recommended to do. This only covers the statistical aspect of it. So statistical power means that for the statistical test you want to implement, you have enough data to reliably be able to detect a certain effect. Generally, we want to have an 80% likelihood, that is the power 1 minus beta 0.8, to find an effect in our data if it is at least medium or big. And we want to find this at a significance threshold of p 0.05. That is a common practice in sports science. This does not cover the aspect whether our sample is representative. So we must account in some topics whether our sample is truly representative for the population that we want to apply our findings on. If we have a topic where it's about elite athletes, our overall population is in general quite small. There are not so many elite athletes in the world. So this is not so much an issue. But if we talk about public health issues and you want to apply the findings for a great population, different age and so on, you need a huge sample to be representative. You need some of older age, some of younger age, you need females, males, you need people of different educational background, maybe different physical activity and so on, to be truly representative. The other aspect is characteristics of your sample. You need to be aware what kind of characteristics are important, which one are interesting and relevant for your study. And you need to be aware what characteristics may affect the independent variables that you want to control for, or important for the dependent variables that you want to test. Because characteristics in a sample, like age, for example, or gender, may affect the result. This may be one such factor, which later on may be an explanation for the observations you do. So you need to collect the information about these characteristics, about all characteristics that may have an influence on the things you are interested in. Then later on, you can control for them in a statistical way, for example. You sometimes, but not always, need to define the selection process, how you accessed athletes or your sample. How did you define to include this individual in your sample and or to exclude it from your sample? This is quite important, especially if you use something like questionnaires or surveys in online tools. This process of using an online tool may affect what kind of sample you accessed, because maybe you only, or you have a tendency to access more people who are familiar with online tools. So maybe in average they are younger and you miss the old people. So maybe it affects the representativeness of your sample, how you selected your sample, or what kind of criteria you chose. And then lastly, and this is the easiest one, is about the ethics. This is a small addition very often to the participants subchapter. It's simply about what is necessary to do this study. You need to inform yourself in advance with your institution and with online guidelines what you can do, how you should do it, and what you will in the end need to provide. Because in many cases, especially for journals, you need to provide a signed consent agreement. So the participant need to sign a paper. Or you need to follow very typically Declaration of Helsinki if you're working with human participants, and so on. So these things, quite easy to find out, and it's not much more than just an addition of 2-3 sentences in terms of your final thesis or final work. But of course, you need to know in advance what you are allowed to do and how you can do it, and then in the end, what you need to report. The second subchapter was about study design, experiments, protocols, and interventions. This is probably the most important aspects regarding this question that you can ask yourself: is the approach you defined, the methodology, the study design, is it suitable to answer my research questions? If you know already, based on how you designed your study, how you want to collect data, when you want to collect data, how you control for side effects, and so on, when you already know at this stage that the data you will get cannot fully answer your research questions, or people may come up with other explanations for any results, then you know it's not a good study design. You want a study design that can answer the research questions with very little doubt by others, and very, very little other potential explanations than the ones that you want to investigate. That means you want to reduce any possible risk that the observations you do, the results you achieve, could be explained by any other fact than the ones you aimed to investigate. That is the important thing you want to achieve through your study design and your methods you choose. More specifically, you want to follow best practices. You want to account for common guidelines and recommendations that you find in the literature for how to implement the experiments, but also for how to process your data and how to analyze your data. And all the decisions you make for the methods section for how to implement your study should be based on rationales supported by references, or at least good, transparent, understandable reasoning. So first, the most important or best way is that for every decision you do, you have a reference that is recommending what you do, or you have a very, very good reasoning for why you do it in this particular way. So nothing should be arbitrary or random. You just do it. Oh, I can use 5 hertz, or I just chose 10 hertz. Never like this. For every decision, there must be a reason. There must be a purpose why. And then the last question is, again, this a little bit, you can use it as a test question for yourself. Is everything you described in the methods, does it have sufficient detail to allow for replication? If someone else can replicate it based on the information you provided in the methods, then it is enough information and the right information. So next we can talk about the instruments and the devices you use. The key question here is, you should ask yourself, what information do you need to provide? And basically, again here, the answer is everything that affects the measurements, because that will affect the data, that will affect the results. And someone else needs to know it in order to replicate the same experiment, achieving the same results if he had the same sample. So you need to include any type of equipment, tools, models, even algorithms. So it doesn't need to be something that you can hold, like a force platform or something. Even an algorithm, like a calculation formula, you need to include in the subchapter, and you need to specify and explain it. You need to provide technical information about all these devices, tools, and so on. And you need to define the settings. For example, what is the sampling frequency of a camera? Settings like this. Sampling frequency is a very good example in many devices because they affect the measurement accuracy greatly, especially if we talk about movement analysis and we want to measure acceleration, for example. A low sampling frequency has a tremendous effect on measurement accuracy, more than on velocity, and much more than on location or displacement. The thing about equipment is that usually equipment should be validated. So if you use an equipment, the equipment is basically claiming to do something, right? A camera is claiming to take a picture. A Vicon system is claiming to measure the location of the markers. An IMU is claiming to measure acceleration, and so on. But companies can develop any equipment they want, right? And whether they say it's a good product or not is not very reliable, and we don't want to trust what a company is saying. We want that other researchers have tested these equipments, and they tested specifically how valid, how accurate and precise they measure. So if other research did this, we want to refer to this research showing that the equipment we used was validated before. So in general, if possible, only use equipment and tools that have been validated before. What you should pay attention for in terms of validation is that validation is always only valid for specific purposes and use cases. So if you use the same equipment for a different purpose than the validation study did, it may not achieve accurate results for your study. Example is, if one study tested the accuracy of an LPS measuring position, and they found out the position data is accurate, then the system, the LPS, is valid for measuring location. If you come and use the same LPS, you collect location data, that's okay. But then based on the location changes, you calculate velocity, and you even calculate acceleration, and maybe based on acceleration, you calculate something else. You did something different with the same data. The previous study did not test if the acceleration was accurate. They tested if the location was accurate. So you cannot say, or it is a little bit premature to conclude that the acceleration data is also accurate, only because the other study said the location data was accurate. So be a little bit careful about how a previous study tested validity and for what exactly the system is valid. The last thing is to use all the tools properly. Usually there are instructions on how to use them, or there are even scientific guidelines. And you should follow these guidelines. A good example is EMG. There are many, because it's quite difficult to collect good EMG data with not so much noises, and collecting the EMG data of the right muscle in the first place. So there is a lot of research developing guidelines how to properly collect EMG data, for example. Then we had the subchapter of cutting data, of processing data, everything you do with the data. One thing could be how to cut data, how to define the start point, the end point that can affect the results. Very important, already mentioned, how to filter data. Do you even filter data? Sometimes not, but sometimes yes. How to filter it? There are different ways. To example, to optimize filter frequency, for example, are fast Fourier transform or residual analysis. I don't want to go into detail here, but I provided the link. Or instead of filtering, you may want to smoothen data. It's a different concept. Do you filter? Do you smoothen? And why? So smoothing in general is more for visualization, but if you calculate with the data and you expect error in a certain frequency, you should filter them, not smoothing them. How to handle outliers. If you have single individuals with extreme values. Using clear and, if possible, common definitions. So everything that is not common, you need to define clearly. And you also, in this subchapter, define the variables that you want to calculate. These variables must be meaningful in helping to answer the research questions. And how to calculate these variables, you should use valid calculations. So these are all the things that may be relevant to be included in how to process data. Once you have the data, what to do with it. Lastly, we have the statistics chapter. First, you need to clarify the software you used. That's quite easy, nothing difficult to understand about. If you used Excel, you just write, I used Excel, same for SPSS, R, and so on. You need to specify the tests that you choose. They must be the right one for your methodology. Like if you do a longitudinal design where you do repeated studies, or a cross-sectional design with different samples, the sample characteristics and the data characteristics, like if certain assumptions are met, like normal distribution are met. So choosing the right tests. A good practice, a quite normal practice, I think, is to include inferential and descriptive statistics. Descriptive is only displaying numbers like mean values and standard deviations of something, or distributions, and inferential would be to test by using p-values, using the chance of likelihood, for finding systematic effects. So all the t-tests, u-tests, correlation, regression, ANOVAs, and so on are inferential. You want to clarify all the statistical tests you conducted, including all specifications of the tests. So you need to specify how the tests was implemented. In some tests, there is not much specification. But for example, it's not enough to say you tested correlation. You need to say you tested it via Spearman or Pearson. Or in ANOVAs, you need to specify if there were other covariates. There are a couple of examples where different specifications that you need to choose in the software can affect the outcome, will affect the outcome. So obviously you need to provide these specifications in order that someone else can replicate them. You should always, if possible, calculate effect sizes. These tell you not only if there was a systematic effect, that is what the p-value is basically telling you, but they tell you how large this effect was. And this is quite important. Is it a big effect, or is it only a small effect? For correlation, the effect size, the typical one, is R, you know. But for other things like t-test, you can use something like Cohen's d. Or for ANOVAs, you can use eta square or partial eta square. So you always should include these effect sizes, telling you how big an effect is. And last, you need to define the benchmarks. What makes an effect large, moderate, small? There are also other references, like previous research, who defined these benchmarks, and you can consult these to use these. A lot of information about some very general things in how to define methodology, what things to watch out for, and then a little bit more specific information about what to include and what to watch out for when you structure your research, what kind of information you need to include and pay attention for. I think we can make a short break here, finishing the methods section. If we have questions, we can ask them either after a short, let's say 5 minutes break, or in the end, because this is like the first half talking about methods, and we can proceed with academic or scientific writing after a short break. So let's make a 5 minutes break first, and then let's see if there are questions, and then we move on. Okay?
Okay, Philip. So please, you can write in the chat box the question. Okay, take a break, Philip. Any question? Ada yang mau menanyakan? Hmm. Ada yang mau bertanya? Oh, Ibu Kalimah. So Philips, maybe the audience in here is very different with before. So before we have that so many from physical education and from sport, and now we have so many background of student. They are from teacher,
Mhm.
elementary school teacher, also headmaster of in school. So maybe the audience now is more different. So we are waiting. Maybe they have any question.
Yeah, yeah,
Bapak
yeah.
Ahmad Saroni.
Maybe it also takes time to process stuff. If there are
Yeah,
questions after the break, let's say
yeah, maybe after the
quarter
break.
past.
So take a break first for 5 minutes.
Yeah, yeah, yeah. Let's start in 4 minutes, quarter past. So 10:15 for me. I think 9:15 for you, right? So let's
Uh,
start there and
okay,
check if there are questions.
15 or 15.
In in
Tim.
four, in 4 minutes.
Okay,
Good.
good.
See you soon.
Ya, see you soon. Eh, oke, Bapak Ibu silakan kalau ada pertanyaan bisa tuliskan di chat box. Jadi tadi semua terkait bagaimana menuliskan manuskrip yang jelas agar mudah diterima di jurnal internasional. Dan Philip merupakan salah satu editor internasional yang ada di Scopus dan beliau editor di Q1, Q2 yang saat ini banyak di sana. Silahkan kalau ada pertanyaan langsung bisa ditulis di chat box. Ini pada diam, bingung atau mupeng? Jelas atau mumet?
Mumet, Miss. Mumet, Bu.
Yang mumet apanya?
Nggak begitu paham bahasanya, Bu.
Nah, makanya belajar, jangan hanya tinju aja. Ayo, belajar. Yang lain? Yang lain? Silahkan. Oh, terima kasih nih ada Pak Simbolon juga nih yang dat yang ikut sambil nunggu ya. 5 menit silahkan yang mau ke belakang, yang mau makan, yang mau minum silahkan. Nanti jam 4 menit lagi kita ke sini. 9.15. Prof Tri, masih nunggu Prof Tri? Lagi break 5 menit Prof Tri. Terima kasih Prof Tri sudah hadir. Tadi Philip masih break 5 menit untuk ke belakang. Setelah jam 9.15 kita mulai kembali.
Miss,
Yeah. Okay.
can I ask a question?
Um, okay. Okay, already. Yeah, please.
Yeah.
Philip.
Well, nice to meet you, Mr. Philip. My name is Andriana Kusuma, and I want to ask you something. What if I submit my manuscript to a journal, but there's no response yet? Well, I hope it contribute to complete my thesis.
Mhm.
What should I do? I submit to the other journal, or I just waiting?
You already submitted to one journal?
Yes. Three months ago, I think, for the assignment.
Yeah, okay.
I'm sorry, my English is not too good.
Yeah. So this situation happens quite often in some journals. Some journals are super fast, and the editors take very long time. What you never should do, never just submit to another journal. That's not allowed. As long as it's submitted in one journal, it's not allowed to submit to another journal. So you need to be patient, but what you can do is to write to the editor, asking very friendly, asking about the state of the manuscript. This is kind of an unnecessary question, of course, because you can log into the platform and you can see, oh, it's with the editor or it's out for review or whatever. But it's kind of indirectly telling them to push a little bit.
Okay.
In a friendly way. I think 3 months is something like a critical time. Below
Yeah.
3 months is quite normal.
Yeah.
More than 3 months, it's getting a little bit much. So I think you can write an email to the editor.
So I just only can stop to hoping if there is email or something that say that my transcript is rejected. Then I can submit to the other journal or something like that.
Yeah, you can submit it to another journal as soon as your submission is not considered anymore from the journal,
Okay.
the first journal. If you wait too long, if they don't speed up the process,
Yeah.
even after 4, 5, 6, 7 months, depends on how much you want to wait, you can at any time retract the submission. You can take it back. You can cancel
Isn't
your
it?
submission.
Okay.
I would usually not recommend doing it unless the quality of the journal is not so important for you and it's more important to get it published very quickly. Otherwise, I would prefer being patient and pushing them a little bit. And then as a last step of effort, push them quite a bit and say that still very friendly, like you apologize for the inconvenience, but you are under severe time pressure and you want to ask if they can find a decision until the next month or the next 2 weeks, because otherwise you need to retract and withdraw the submission.
Okay.
And if they still don't do it, you just cancel the submission after 2 weeks or whatever deadline you set for yourself, and then you can send it to another journal again.
Okay. Thank you, Mr. Philip. The other question, may I?
Sure.
About the Scopus journal. I'm wondering what the first what is it? When editor sees my manuscript, what the first thing that they see? Is it my English, or I mean in my English in my transcript, or the content of my transcript?
So the associate editor or the section editor is the person who sees it first to make the general decision, and he will for sure see the title, of course, and for sure he will see the abstract. In many cases, I assume that they do not read the full text.
Wow.
They read the abstract, they make a rough decision for themselves if it is decent enough to go for reviewers or not, and then they just send it out.
Okay, I see.
In my experience, many editors are too lazy to read the full text, and the reviewers should do the job. So it's super important that the abstract is very good. It's important that the English is decent. I think it's not necessary to be perfect, but at least no grammatical, like clear language errors, and clear language that it's easy and clear to understand. If it is hard to understand, then it's just super annoying for the editor already to read the abstract, and he doesn't want to bother with it.
Okay, I see. Thank you, Mr. Philip. I really thank you.
You're welcome.
Thank you, Adriana. Philips, there is also so many questions in the chat box. They need to say directly or just
so the
reading from the
was
chat box.
Yeah, okay. So I go through them quickly one by one. So Sarah Sitra Fanita asking for how to choose the journal for the manuscript. I personally go through the impact factor list from top to bottom, and I have roughly an idea how strong I think is my own manuscript. Maybe it's a good one, or maybe it was something I know myself is not so good because it's just a little bit rest data I had and I did something additional quickly. So I make an assessment. Do I choose something in Q1 or Q2, something like this? And basically I personally have a list of all journals that are ranked Q1, Q2, 3, 4, with notes what kind of scope is covered by these journals, and some relevant information for me, like do they charge fees? Are they what is the word count they require? So I choose first based on the rank. Second, of course, only the ones where the scope of the journal is suitable. That is extremely important. So you should read the scope and the aims on their website. And then I just choose whether I have budget or not. Free for submission journal where the scope is fitting and the rank is as high as possible. Basically, I choose like this.
Okay.
Maybe one experience. In the beginning, I avoided some journals where I had bad experiences, because it took super long time, stuff like this. At some point, I changed my opinion about this because I was kind of forced to submit to the same journal which I avoided many years ago, and I had a very good experience. So I think it may depend on the associate editor and make a big difference. So I would not easily exclude a journal just because of one or two bad experiences. Maybe next time you get to a different associate editor, and then it's completely fine.
Okay, thank you. Maybe another question. Just sometimes I will confuse how to relate between the other journal to another journal for the manuscript. Sometimes there's a lot of citation, right, for the journal. So I'm still confusing how to make it one.
A lot of citation? What do you mean?
Yeah, about the journal. So I'd like to make a lot of journal being one, but there must be a lot of citation, right, for the manuscript.
You mean that you use a lot of citation from the journal where you submit?
Yeah.
To be honest, I don't know if this really matters so much. I think it's not harmful, of course, but to be honest, I don't even believe that editors or many editors take the time and the effort to go through your reference list and counting how many times you cite
No.
it from their own journal. Because there are also only individuals. They are a professor somewhere. Yes, they are working for this journal, but they are also working for other journals and so on. Why should they care so much? To be honest, I wouldn't do it. I just want to see if the references are supporting the statements they do, no matter which journal. So I honestly think that's probably not too important.
Okay, thank you.
The downside of focusing on
manuscript.
citations from a specific journal is also, if this journal rejects your manuscript, then what do you do for the next submission? You change all the references looking for the new journal. So it's super much effort anyway.
Okay, thank you. That's all my question.
Okay.
There was a question, what do you think about articles related to developing models, specifically related to Telegram app platform services? So I don't know specifically Telegram app platform services, but articles that develop something, it's very important that these findings are actually transferable and applicable for other people. For larger populations. That means you usually need a great sample. You cannot develop a model or an algorithm based on a sample with 20 participants. Even if the statistical test, the power analysis tells you, oh, for this test, 20 is good enough. Your statistical power is strong, you will find a significant result. This would not be representative. So if you develop something, you want other people to apply what you developed. So it must be applicable. It must be transferable. So you must have a great sample to be sure that if other people do it with a different sample, that what you developed still works. So that is, I think, quite often a difficulty. And sometimes a problem if an article is about developing something and the sample size is small. That is certainly a big problem.
So I think also it's from Mr. Sahli. It's related.
And the next one, what methodology do we use so that our journal is published in an international journal? There is no general answer to this. So the best general answer I can give is what I try to point out in the slides, that the methods you choose must be able to answer the research questions in a way that it allows only one explanation. And this explanation is the one you want to investigate. If you achieve this, then your methodology is good. It depends on the specific research topic, on the specific research questions, how this will look like. So that's why there is no general answer. So for each research question, for each topic, a different methodology is the right one. But the one thing that goes for all researchers is what I said, methods in a way that answer the question and leave only one possible explanation. That would be perfect and ideal. It's very hard to achieve this, but this should be the aim. Specifically, my plan is to write an article about the use of Telegram app platform in live streaming auto lectures. Does this article have implications for copyright infringement? What do you think? Whatever you develop and whatever you publish, you don't have the rights of it anymore. So if you publish an algorithm or information about a model or something, this information is public. The rights of the article you actually give to the publisher. So as the author, you don't even have the rights anymore. In most cases, depends on the journal, of course, but usually it's like this. So you cannot expect that you have copyright of an algorithm that you published. If you want to keep the copyright, then you can publish something else. You can say that there was an algorithm developed and it works roughly like this, but you don't specify the single numbers or some single essential numbers. And then you test how well the algorithm is working. So that means someone cannot copy the exact algorithm. It's an in-house production then. That is completely possible to do. But if you specify the entire algorithm, like with all the specifications, and someone can copy paste from your article the algorithm and run the same stuff, then don't expect that you have the copyright anymore. It is possible to not specify all these things. And sometimes if you are not the developer, you usually don't have it as a scientist. So I was doing research about local positioning systems using from a company. I don't have the algorithm. I don't even know. So what I can do is I can still test it, how well it works by applying it. But in the article I write, it's an in-house produced algorithm. I don't know it. So if you are the developer, you could do something similar. You don't need to specify everything to give every copyright relevant information away. Okay, that was the last question so far. If we have more questions after the next part about scientific writing, we can still answer them. For now, I suggest I share my screen again. Here. And we can move on with how to write a scientific article. I already mentioned that writing a scientific article is a little bit different, or a scientific thesis is a little bit different than just writing a text in English, a novel or any other article. Academic scientific writing is a little bit different in style and has specific requirements. Let's start with the general instruction that we talked about earlier. And it is very important that if we follow through this structure, that we follow from one chapter to the next one in a stringent way. One chapter is clearly leading to the next one, clearly leading to the next one. So everything is arranged in a way that it makes sense. So as I said earlier, the introduction is the basis, the baseline, and everything later builds on. You have this introduction giving information. At the end of the introduction, it must be very clear and make a lot of sense why you choose certain methods. The methods directly come from the information from the introduction, from the research questions. At the end of the methods, it must be very clear why you display certain results. Put it in very simple words. If you describe in the methods you run an ANOVA, of course, it's very clear that in the results section, you have the results of an ANOVA. Something like this. At the end of the results section, it should be quite clear what kind of results need to be discussed. At the end of the discussion section, it should be clear how to draw the conclusions. Or in other words, if you write your introduction section and you give it to someone else, hopefully, if you did an amazingly great job, because in practice that's quite difficult, the other person will define similar methods than you do to answer these research questions. Or next step, at the end of the methods section, You give the method section to someone else. He's also completing the study, and he will display the results in a somewhat similar fashion, or at least the same results, maybe in a different style, but the same results as you do. Hopefully, the discussion will also be stringently based on the results and the information provided in the introduction. So having this clear line, everything builds up onto each other. This kind of stringency is important to maintain this at all levels, at macro level, meso level, and micro level. Macro at the grand scope of things, like from one chapter to the next one. Meso within the single chapters, and micro for each sentence. So this is what you see here. Macro level refers to chapters. So a clear line following from introduction to methods to results to discussion to conclusion. The meso level is within one section, for example, within the introduction section, checking whether the flow from one paragraph to the next one makes sense. No jumping around. For the reader, it must feel natural, and it must feel logically and reasonable why to go from the content of one paragraph to the next paragraph to the next paragraph, and so on. And micro level would mean from one sentence, specific sentence, to the next one, to the next one, to the next one. Again, not jumping around in terms of topics. First talking about sprint performance, then what is the effect of jumping, then going back to nutrition, then again sprinting, and so on. No jumping around. Stringently from one thing to the next thing. As if you have a string or a pathway that is leading the direction to go. Difficult question is how to do this, how to achieve this good structure. This is now just my personal opinion. What I think you should not do is the so-called think and write. Making your thoughts, thinking something, and writing in the same time the manuscript. If you think and write, you will write what comes up into your mind at this time. It's not necessarily structured in a meaningful way. So what happens then is your mind is having a thought, and then the next second you have another thought, and then 2 minutes later you have the same thought as before, but with different information. So that's not well structured. That is this jumping around from one topic or one aspect to the other one. So don't think and write in the same time. What I think is a good practice, to go from the macro level to the micro level, from a general description to a specific description, and to first think, then make a concept of how you can put these thoughts together in a meaningful way, and then specify the single concepts. And the more you specify each single concept, in the end, you will write down these concepts. And I will explain a little bit more what I mean by doing this. During the specification, it may happen very often that you think about something again, so you rethink again and again, and you get new ideas. Or you check something in the literature again, and you get even new information. So that may change your thinking process, that may lead to readjustments, rearrangements in how to conceptualize. This conceptualization can be expressed by, if I go back one slide, by paraphrasing each paragraph. So if you take a look at the meso level, what you can do is, if you have a text and you want to understand its structure, you can paraphrase each paragraph, meaning you read the entire paragraph, only one paragraph, and you give it a paraphrase, like a short title. What is the key content of this paragraph? And then if you read every single sentence in this paragraph, you can identify if this sentence adds information or is related to the paraphrases, to this short title. It should be related to what this paragraph is about. If it is something different, it doesn't belong there. So that's the method of paraphrasing stuff. This works if you already have a text, either if you assess a different text from someone else who wrote it, or if you try to improve your own text, so you already have a text. You can make this to test it. If you don't have your own text already, so you start with a blank file, what I, in fact, do is, in the beginning, you have a blank Word file. And I start just with the structure at the macro level, saying introduction, methods, results, discussion, conclusion. So this is the basic concept. I conceptualized the macro level of my article. If I want to have subchapters, I specify the subchapters. For example, I just wrote, okay, first I talk about participants, then study design, protocols, processing, statistics, something like this, not more like this. So I start with a blank, empty Word file, introduction, methods, sample, data collection, data analysis, statistics, results, discussion, and so on. And then I jump into each chapter, for example, introduction, and I think about the key titles for each paragraph. What are important aspects? So what is an important aspect I should cover in this introduction? Maybe my work is about, currently I'm working a lot in sprinting, so I come up with these sprinting examples all the time. So maybe your research is about sprinting, and it's about sprinting performance. Different performance determinants are important for sprinting. Okay, then I write down performance determinants for sprinting. Then I think, oh, maybe it's first important to describe biomechanically what is happening in sprinting. So what is sprinting? How does it work mechanically? So I write down sprinting mechanics. Now I already realized, well, I think it's more important first to know the sprinting mechanics and then to define which of these mechanics are important for performance. So I changed the order. I first must describe the sprinting mechanics and then the sprinting determinants that determine the performance. So I make this list like a subchapter within the subchapter. And then I go into every single subchapter. So what are these sprint performance determinants? So I need to consult the literature, of course. Then I find out, oh, maybe it's long stride length, maybe it's short contact time, and so on. So I specify what are these important factors that determine sprint performance. So I go into more and more and more detail, but I start with the very basic things at the macro level, going to meso level, and specifying it more and more and more. So then I have my list of performance determinants that are important. And then I may specify when are they important? How did other research find out that they are important? Are they important for all groups? And so on. All the information I can get that is relevant for my topic. And you already see at each step, I add more and more information. The information is getting more and more specific. And in the end, I have so much information for all the relevant stuff structured in a meaningful way, because I can easily rearrange them if I realize, oh, it's important to first mention this one and then the other thing. So that actually writing down the stuff and making full sentences to phrase it is getting quite simple because I have collected all the specific information already. So in the end, it's just putting the information into a full phrase. a general thing for the arrangement, the structure within the paragraphs or within the chapters is in all chapters to go from general to specific. You first start with something broad and general, and then you narrow it down, and the thing becomes more and more specific. And then in the end, specifically addressing the research questions you have. So that's the one thing, from general to specific. Don't start specifically. The other thing is you want to provide fundamental knowledge first. So information that is essential, that is fundamental to understand the next steps, you should bring them up first. Another aspect is logical stringency. What this means is that the reader's thinking is aligned with the author's writing. So what the author is writing is what the reader is also perceiving, is reading, and the reader is having thoughts based on what you write. If what the reader is thinking is aligned with what the author is writing next, everything it makes a lot of sense. The reader can understand why you take a certain pathway, why you write about this next aspect, because it seems logical based on what you wrote before that you need to address something more specific afterwards. So that is really difficult to test for yourself. One way, of course, is writing an article with other people together. So you write something, someone else is reading it, and he will tell you where it makes sense or where it feels off, or where it feels like, why do you write this? Why you don't write something else? For yourself, it's very hard to test. The only thing I can really recommend is writing something, then stopping it, leaving it, focusing on something else, on a different chapter or a different kind of work, not on this manuscript, maybe you have a different research project, and then coming back to the text and reading it again and check how it feels. Because after a break, your mind may change. You may have forgotten what you wrote. So if I write something, I leave it for 1 week, I work on a different project, and I get back to the text, my mindset has changed. My mindset is a different one. I have a different mood. I forgot some details, what I wrote. I forgot the thoughts that I have when I was writing. So I enter this text, even though it's my own text, I come back to it a little bit with a mind of a different person. My person 1 week later is changed a little bit. So that's the only way I can come up with by checking by myself. The last aspect for having a meaningful structure is considering the timeline of when you do something. This is especially relevant for the methods section. So usually you want to mention things first that you actually do first. So matching the structure of the article with the timeline of implementation. So these 4 things, I think if you try to implement them, this will improve the structure at the meso level, so within your chapters. A visualization of bad or good or optimal structuring would look like this, that in the bad example, you jump around between different topics, from one topic to the next one. They are not related. Sometimes you can even jump back to the same topic. So first paragraph, you talk about stretch shortening cycle, then you talk about jumping movements, then you talk about effects of sex. And then in the fourth paragraph, you talk again about stretching shortening cycle. That would be jumping around, coming even back to a topic that you already addressed. So this jumping around would be a bad structure. It's better if the pathway has a clear line, a clear vision from point A to point F where to go in a straight line. So at each single time point of your manuscript, it makes sense. The reader can understand where you go to, what is your goal. And the only difference between a good structure and what I visualized as the best structure at the bottom is the distance between these single steps. If the distance changes all the time, it feels for the reader that some aspects are very rushed, very little information, maybe not enough, and then other sections are super long, a lot of information, much more than needed. So you follow in both cases a straight line. It's very clear why you go this pathway, why you write something, why it's necessary for your study, and it stringently leads from, for example, the beginning of an introduction to the end, to the questions, but the pacing is different. Sometimes it feels too slow, too much information, irrelevant information. Sometimes it feels too rushed, not enough information. So to have this straight line, to have this reasonable pathway from A to F, from start to end, you always have a link between paragraphs or a link between statements. So if you don't have a link, it feels like jumping around. A link is often created if you reason well. So I first give a reason and then I give a consequence. So there is a clear link why this consequence is created by a certain cause or by a certain reason. There are words that express these links. For example, therefore, nevertheless, in contrast. These are examples of words where you can express this link between sentences through your language. The thing is, you can fake this link, even though it doesn't exist in terms of content, you can fake it by just using these words. So in terms of content of what you wrote in your sentences, sentence A and sentence B, there must not be, it is possible that there is no link between the content of the sentence, but you can still, of course, use the word therefore, even though it is no consequence. Or you can use the word in contrast, even though there is no contrast. It's not related to each other. So my advice, because that happens quite frequently, don't use these linking words if it is not lining up with the content of your statements. Again, to test this is simply remove these words, remove therefore, remove nevertheless, remove in contrast, and so on, and check if the next sentence makes sense and it is clear how this sentence is linked to the previous one. If in terms of content, it is clear that the one thing is a consequence of the other one, a reader will understand this consequence even if you don't use in consequence of this or consequently. So you don't need these words if in terms of content, this relationship between the sentences is made very clearly. I want to specify a little bit now at the micro level. So we started with the macro level, going from one chapter to the next one. Meso level, about paraphrasing to check if the single paragraphs are aligned in a meaningful way. Now going into the micro level, when it is about actual phrasing, like writing the single sentences. That requires also appropriate wording. For this, obviously, it requires a sufficient level of language skill, English skill, if you write in English. But there are some rules that apply specifically for academic or scientific writing, and this has nothing to do with general English skills. So even if you are an English native speaker, because you grew up in the UK or US or whatsoever, you need to learn these things and consider these things if you write a scientific article compared to a newspaper article. So the one general thing is this KISS rule: keep it simple, stupid. What this implies is to remove everything unnecessary or redundant. In scientific writing, we don't want to waste space or time of the reader. We don't want to be redundant, meaning to repeat ourselves, to repeat the same piece of information. That is redundancy. So whenever you find something, some piece of information that was given already before, that is redundancy. That is something we want to remove. We don't want to repeat ourselves. This goes for entire paragraphs, for sentences, even for single words. If a single word is not giving meaningful information or information that was given already before, we don't need it. That means we want to use as few words, not many, as required. And also the structure of our sentences should be as simple as possible, as long as we can deliver the desired message accurately and clearly. So the first goal, of course, is we want to deliver what we want to deliver in a very accurate, precise, and clear fashion. But we want to use as few words as possible and to make it as simple as possible. Why? Because it can happen very often that scientific content is very difficult to understand. Scientific stuff can be quite complicated and complex. So if the topic is already complicated by its nature, we don't want to make the language even more complicated. We want to use a very simple and easy language to make it easier to understand and focus entirely on the content, not so much on the language. But we need to deliver the message accurately, precisely, and very clearly. That's the most important thing. So it's always better if we can provide the same message, the same information, but in less space, little space. That's always better than talking for 5 pages about the same information. So what you can test for yourself again, what you can ask yourself is, actually, for every single phrase, for every single sentence, can you somehow simplify the sentence or make it shorter, more easy to understand? This is not the primary goal, of course. The primary goal is that you deliver the message clearly, but as long as you deliver it clearly, you can always ask yourself, can I make it somehow more simple, shorter, easier to understand? Then it would be better. One example where it doesn't depend on content, it doesn't depend on the field you're in, and it almost always applies, is replacing the structure of "in order to" by "just to." So in order to reduce the space I need, I can remove some words. In the same way, I can express the same message by to reduce the space I need, I can remove some words. There is no meaning, no necessity of using "in order." I can achieve the same message by just saying "to." This is just one example where it's, and there are many examples like this, but one example where it's not even about changing words, it's just reducing words. So the KISS principle is the important thing. Keep stuff simple and understandable for the most stupid person possible. in terms of language, because the content, the topic already that you investigate is complicated. So you don't want to make it even more complicated by using complicated language. I mentioned it's important to deliver your message accurately and clearly. That means you need to use words correctly. And when you are working in the medical field, thankfully, there is a manual of style provided by the American Medical Association. You can find it under the STOI number. It contains many words. It's like a dictionary explaining what exactly they mean and why they are specifically important to correctly use them in medical scientific context. I want to give some few examples. And this is directly from this manual. So for example, the words abnormal, normal, or negative and positive. They say examinations and laboratory tests and studies are not abnormal, normal, negative, or positive. These adjectives apply to observations, to the results or findings, not to the test itself. So it's not a negative COVID test, it's a negative COVID test result. So the result, the observation, is negative or positive or normal, abnormal, but then you needed to define what is normal, what is abnormal. The result, the observation, is negative or positive, not a test itself. Accident or accidental as an adjective is considered by the public health community to be imprecise. If you refer to something as an accident, it can be anything. You don't know, you don't provide any information about what was causing the accident. So an accident can be a crash, it can be a shooting, a collision, just to name some examples. So each of these words is one word, like accident is one word. So in terms of space that you use, it's no difference if you use the word accident or if you specify the information, the event, by saying shooting or collision. So you can use the same number of words, means same space, but provide more precise information. In scientific writing, it's always about improving density, a lot of information in limited space, because we are limited by word count, maybe for 3,000 words. So you want to put as much relevant information into these 3,000 words as possible. Something that you may encounter is also acute and chronic. These terms describe symptoms, conditions, or diseases. They refer to duration, not to how severe something is. So acute and chronic means how long something lasts, not how severe it is. Important difference. Avoid the use of acute and chronic to describe patients, parts of body, treatment, or medication. So a medication is not chronic or acute. A patient is not chronic or acute. A disease can be chronic or acute. A patient can be a long-term user, or a treatment can be implemented in a long-term intervention fashion. But the disease is chronic or acute. Another important difference, adapt and adopt. That is something also a native speaker will know. That's a pure language thing, not scientifically specific, but happens very often in writing. You can find this error quite often, so I included it. Adapt means to modify or to change something to fit another circumstance or requirement. Adopt means to take something and make it your own. So if someone else uses a model or develops a model and I adopt it, it means I take the model and I use it in my own thing, in my own way. If I adapt, this model, it means I change the model. So it's a very important difference. Adverse effects and side effects. Very often people talk about side effects. What they actually mean is adverse effects. Adverse provides more information because it implies that it is a negative, a detrimental effect. Whereas a side effect can also be a positive effect. Side effect just means it's an effect that is not the main effect. It just comes with another main effect that I focused on. It can either be negative or positive, beneficial or detrimental. But adverse adds the information using the same word count that it is negative. Affect and effect is also another subtle difference, like adopt and adapt, that you can pay attention for because it's quite likely to use these words. Affect means to have an influence, and effect means that you cause something. So you are causing a certain effect, means you effect something. But if you have an influence on an output, you affect something. The difference is obviously if you influence a recovery, you just have a moderator, for example, that can change the recovery. If you effect the recovery, you are solely causing, you are creating this recovery. Affect as a noun, funnily, I just saw this week in an article used incorrectly. An affect is an immediate expression of an emotion. It's very often used as a part of psychiatric diagnostic terminology. So if someone has emotion and he acts immediately out of this emotion, that's an affect. An effect is the outcome, the result. So a study or an intervention can have an effect on your performance. It doesn't have an affect. Affect is a human going crazy and then killing people out of affect. As, because, and since, they can all used for expressing for the reason that something else is happening, and you should avoid using them when they can be misunderstood in a different way. So since can also be misunderstood as a definition of starting point, of like a timing point. For example, so this is 3 words, can be used interchangeable, but be careful that if you want to express a reason for something, that the word you're using as, because, of since cannot misunderstood in a different context. When you refer to your own piece of work, note that an article is something that is already published. Same goes for a paper. And a manuscript is something that is unpublished. So as long as you didn't publish your text yet, it's not an article, it's a manuscript. It's a manuscript for an article, maybe, or it's an article manuscript, or it's a manuscript for a paper submission. But at this stage, it's only a manuscript. Once it's published, it's a manuscript or a paper. Association and relationship is also interesting. Whenever you do analysis where you use correlation, for example, which may happen quite likely, association is a connection between 2 variables in which one does not necessarily cause the other, whereas relationship implies cause and effect. That is the definition of this manual from the American Association. What is clear based on this definition is that association is a little bit looser than relationship. relationship implying cause and effect, whereas association just means there is some sort of connection, but maybe no cause of effect. I must say I don't agree 100% with this definition, because when we can test relationship statistically. This is what we do when we do correlation analysis and so on. We test the linear relationship between two variables, for example. That does not necessarily imply cause and effect. That is what often we want to see, and we wish to find a cause and effect, but only because there is a linear statistical relationship between the two things doesn't mean there is cause and effect. But I still do agree that association is a looser term, more flexible than relationship. Association is usually more used when you observe something and it is well, associated with something else in the way of very often you observe also the other thing, or it is believed to affect something. For example, you could say biomechanical characteristics in your landing are associated with injury risk. If you have higher peak forces could be associated with increased risk. It basically means there is a connection. People believe there is a connection, but it doesn't necessarily mean that there was a relationship that was tested, like you actually tested multiple people jumping and you tested the correlation between the peak force and how many times injuries occur. Then, if that was done, then I would talk about a relationship. Otherwise, it's easy to talk about association. And you may face it because if you use the term relationship and a reviewer or supervisor may justified argue that how do you know there is a relationship? It was not tested. Please provide me some reference. And then you cannot provide. So you cannot refer to it as a relationship, but you can still say it's associated with risks because, for example, based on a theoretical framework, it makes sense to assume this link with injury. So it's a little bit looser. Due to, caused by can be different than because of and owing to. These are also some examples where it's quite specific, similar to since, as, and because. You want to avoid misunderstandings. Due to and caused by are adjectival phrases. Owing to and because of are adverbial phrases. The use of due to in both situations can alter a sentence meaning. So if you exchange them, it can actually change the meaning of a sentence. For example, if you say survivors of child abuse tend to enter abusive relationships due to intrapsychic conflicts, it means relationships that are caused by. So survivors of child abuse tend to enter abusive relationships due to intrapsychic conflict means that these relationships are caused by the intrapsychic conflicts. That is a different meaning than if you say because of intrapsychic conflicts, survivors of child abuse tend to enter abusive relationships. That can be different. You will rarely encounter these difficulties, but it's an example of more nuanced differences. What you encounter very often probably is the difference between can and may. Pay attention when you use these. Can refers to the ability or the power to do something, whereas may refers to a permission or a likelihood. So if you say I can, it means it is possible. If you say I may, it means that you have the permission or there is a high likelihood of doing something. Someone, for example, someone can always use a certain intervention to improve their health. Maybe it's not working. So you should say, you may use this intervention to improve your health, because there is a high chance, a high likelihood to improve your health. It's clear that you can use it. You have the power, you have the ability to use it, but it doesn't mean that it has a high chance to actually improve your health. Effective and efficient. So efficient means the ratio of input versus output, whereas effective just means it creates an effect. Thus, therefore, hence. Therefore and hence are basically the same, but only a little bit more formal. But thus means that it is a consequence achieved in a certain way. So if you refer to a certain way that maybe you explained before, and then you say, thus, you can do something, it literally means you can do something in this way. Therefore and hence doesn't refer to a specific way of doing it. It just expresses the next sentence is a consequence of the previous one. Okay, to summarize the content of these slides about writing, I think important parts is to have a stringent and logical text structure. So to structure your text at all levels, that it makes sense going from one topic to the next one, having the same pace. It's very clear for the reader to follow you, to understand why you mention all the information that you mentioned in this sequence to this degree or amount of information that you provided. To always write in a very simple, short way. So your writing style, the sentence length should be rather short, not super long, not very complex, like having another relative cause, another one into one huge, gigantic text sentence. And in general, yeah, making it short and simple, easy to understand in terms of language. Use rational language, no emotional language, not being manipulative. You don't want to manipulate the reader's opinion or tendency of thinking. You want to be rational, you want to be precise about facts. No manipulation going on, which you find a lot in the language used in non-academic writings, newspapers, magazines, and so on. No redundancy is one key issue. So whenever you repeat stuff or you provide information that was given already before, that would be redundancy. Try to avoid this. Try to maximize the density of your information. Put a lot of information in short space, in little space. Be precise about the information you provide and be correct. So both these things together mean you want to accurately express your ideas and the information you want to deliver. These two things also mean no ambiguity. Things should not be possible to be interpreted in the one way or the other way. The way how you write or how to speak, there should be only one way of how to understand and how to interpret things. If you say something and one person understands it in this way and another person understands it in another way, you have this problem of ambiguity. So be very clear and everyone understands the same thing. Good. I think enough content for finishing now. I have some other stuff that is included in this slide. It follows here after this slide. It's practical examples going through a practical text analysis. going through single steps, what is good, what is bad. If it is interesting for you, you can go through it at home. You can also contact me. You see my website down there. On the website, you can find my email address. I uploaded the slides on this link, so you can take a screenshot,
Ini aja,
take a picture.
biar waraknya cepat.
This link is online for 1 week. So within 1 week, you can just open the link, download these slides I provided. And if you have any questions now, you can ask them now. If you come up with other questions in the near future, you can send me an email.
Okay. Thank you very much, Dr. Philip X. Fuchs. This very precious and essential information for students and how to make a good, excellent manuscript. Okay, so any else question from students? Or
I see the
Okay.
one. It seems we missed one question before.
oh, Mr. Okay.
Here is it again. What do you think about writers with a sports background who are required to compose the best narrative in non-native language? What is your suggestion? By narrative, do you mean specifically a narrative review article, or what is meant by composing the best narrative? Maybe you can specify the question in the chat box. In the meanwhile, I can share some thoughts about it. When writing an article in a non-native language, I think the best or a good approach, in my opinion, is depending on your language skill. If your language skill is super bad, then it is unfortunately probably the best choice to write your text in your native language and then use translation software, AI bots, and so on for translating. Modern tools are doing an amazing job, actually. If your language skill is decent enough to express your ideas precisely, I think that's the critical level threshold. If you feel confident enough to precisely express your ideas, then I would suggest writing the text in English, your own text, and then using modern tools, AI chats, and so on, to just improve the writing of your own text. You can, and I would do this in multiple steps. I would do it first step to remove all grammatical errors, like where it's clearly a language error where you did something wrong. And then in the next step, running a second step of improvement to improve the writing style. So saying something like, if you use Bard or ChatGPT or something like this, I don't know if this is allowed in your university, you need to check. But in general, you can specify, like giving an instruction what you need. I need to write a scientific article. The requirements for a scientific article are not having redundancy, being precise in wording, and so on. Like, you can specify the things I provided in the slides, and then please improve the text I prepared so far, and then you copy paste the text you did. I think that's one way how you can improve your writing for a non-native language text that you need to write. The problem when you are not writing your own text in English and you write it in your own native language and then you translate it, is that you lose valuable precision. Because the translation, it's pretty good, but sometimes words are used in a different way, so that the translation in fact is correct if you just use the word, but then in context or in this field, it would be worded differently. And then you can have this loss of precision, and you are not so sure because you just get the translation if your message was precisely reflected in this translation. Of course, you can then check the translation, and if your language level is good enough, you can make your own assessment if the translation is precisely expressing the ideas you wanted to in the way that you wanted to. Then it's also okay. But you need to check. You cannot take it for granted that any translation service is doing it in a proper way. And maybe a small side note, even if you specify the requirements of a scientific text and you use modern translation tools, AI-based translation tools, the outcomes are they are quite good, but they are not ideal. So in the very long run, it's certainly good enough for writing a thesis, 100% sure. But in the long run, if you want to become a researcher or doing like good stuff in high quality journals, you should learn these things and improve these skills through own practice. Yeah, there is. Okay, great. This seemed to help. There is another hand raising by Sarah Sakia.
Sarah Sakia.
Okay.
Okay.
Okay. Thank you. I'm a bit curious and I want to ask your opinion, Mr. Phillips, about how can we start to encourage ourselves to start writing a scientific writing manuscript, because sometimes what I mean is, we need to be construct from a good research method, or just put everything together what in our mind and construct it in a scientific manuscript?
I am a huge fan of following the same structure like the manuscript structure in your own procedure. That means I think it's very important to work on the introduction section first, even writing it down before implementing data collection. And this may be also encouraging for the writing, because then the single writing processes are split into multiple processes, and each process is smaller then. Otherwise, you are in the end of a project and you need to write an entire manuscript, which is a huge piece of work to do. Instead, if you just try to only write the introduction, it's not so much work. It's easier to write an introduction than writing the entire manuscript. So you split the work into smaller pieces, which is maybe motivating or encouraging to overcome this problem of starting writing. And then you also have some outcome success earlier on. If you have a solid introduction, if you have a solid method section, then you implement the data collection. For me, that is a little bit more motivating because of smaller steps, and also because I don't need to write an entire manuscript then for 1 month or something. I just write for 2 months, like introduction and methods, and then I change the type of work. So I have this kind of, doing something new, not writing all the time and then doing data collection all the time. No, I do a little bit writing, introduction and methods, then I change the type of work, going to the lab, doing data collection analysis, and then I change the type of work again, doing some writing of results and discussion and so on. For me, that's a little bit more encouraging than doing long-term writing, nothing else, and then long-term analysis, doing nothing else. It's more interesting for me, at least, to at a daily basis or weekly basis to have more change, more variety in types of work.
Okay, thank you, Philips.
You're welcome.
Any else question? Please raise your hand or you can chat. Okay, write it in the chat. Mr. Adi Slamet, you want asking something? Okay. Okay. Miss Asri? No? So, any else question? Okay. So, Philip, it is your time is enough or you still have time in here?
Good. No, if there are no other questions, I am happy if everything is clear. If something turns out to not be so clear in the next days or weeks, I will gladly answer future questions also that you can send via email.
Yeah, actually in Indonesia, like student Indonesia, they always writing the method is not clear. So this is why always easily to reject it.
Yeah.
And you already share to us about the essential and how to write the methods very clear. And I hope all students can understand. And if any else question, the student can directly ask to Dr. Phillips.
Yep. Actually, I would have one question. How does your university handle AI supported chatbots?
AI?
Yeah, like
AI
ChatGPT and so on.
ChatGPT. Actually, I don't know. You can ask him.
Okay.
So maybe they use it.
No. I mean, not if students are using it or not. I mean, is the university having regulations specifically saying it's allowed or it's not allowed?
Until now, the university didn't have any some issue or any statement about the ChatGPT.
Okay.
Yeah, not yet have some rule about that.
Okay.
Maybe from the government, usually from the Minister of Education, they will share about the statement about the EA or this is can use or not.
Yeah. Okay. We have one more question just coming up, and I think it's a very important question. Can we use AI in conducting previous literature analysis? Is it effective in the preparation of articles? So the second question, is it effective in preparation of articles? To some degrees, for some specific things, yes, for sure. Like, for example, language improvement. Or also correcting wording and so on. It's, for example, not very effective in reducing redundancy across paragraphs. In single statements, in single sentences, ChatGPT and so on are good in reducing redundancy, but if there is content redundancy across paragraphs, is not good in understanding it. At least in the free 3.5 version. I don't know. I don't pay for the 4.0 version. Whenever I talk, because I have some colleagues working in IT and so on, so whenever I say something's in ChatGPT or something is are not so good, the final argument they bring is in the paid version it's always perfect. So yeah, I cannot know. I don't pay for it. But for the free version, definitely not perfect. The first question is the interesting one. Can we use AI in conducting previous literature analysis? Not really. It depends, of course, on the way how the AI tool you use is working, what kind of sources it uses. because they differ. So some use online sources, some only use the previously available online sources until a certain time point. So this is the source that the model was trained on. So I think I'm not 100% sure what is the updated state, but I believe that the current ChatGPT 3 version, the 3.5, is still working based on a model that was trained by the online source until end of 21, I think, but I'm not sure. But as long as a tool is working like this, first of all, you need to know it's not updated. It's only until end of 21. But more importantly, it may have had no access to scientific literature because it was not open access. So depending on what is the source material, how this AI tool was trained, it may not have been trained based on scientific literature, or only in a very limited fashion. And then you don't know, even if it is, or even if it includes online material, current online material in this year, in this month and week, and even if it accesses scientific articles because they are open access, or even if the way how the model works, different companies or so, can access non-open access articles, which I want to stress is usually not the case. Even then, you don't know how the tool is assessing the weight or giving weight to different kinds of sources. So you don't know if it evaluates the scientific article from the #1 journal in the world in the same way, giving it the same weight, like a random newspaper article talking about the same topic that was published in, I don't know, in an American New York newspaper. So you don't know how it's assessing the information. And usually you need to expect that it has rather limited access to what is the actual relevant scientific literature. So unless you have an AI tool where you exactly know what kind of sources it uses or it's trained on, and you know exactly how it assesses the value of this information, I would highly, highly ill-advise using it for literature analysis. That is not working. Also, the concept of language-based AI tools is not about reflecting accurate information. This is not the goal of the tool. The tool is reflecting not information, but a series of words, actually, that make the most sense based on the training it received. This has not necessarily to do anything with correctness of information. In fact, it will give you an answer that can be factual, completely incorrect, completely wrong information, just because it makes the most sense in terms of how to construct a sentence. And you can even provoke this. Like I have some slides because I was mentioning this in one of my courses and how students can use it and how they should not use it. And I was experimenting with ChatGPT provoking these wrong answers, where you can see that ChatGPT is giving absolutely incorrect answer, like the facts are the opposite, but that's what it's doing. And you can force it by the way how you ask. So there is no guarantee that the information it gives is correct. That's not how the AI is working and programmed. So yeah, short answer, no. Don't use for literature.
Yeah. But now Turnitin also can check AI.
Sorry?
So we use like a Turnitin for plagiarism. So this is also can check this use like a ChatGPT or not. So detected by Turnitin.
Mhm.
Mhm.
I use it for, so I also use it for checking grammatical errors or something, because it can happen to everyone. I also use it for summarizing content. Sometimes even for a first draft of an abstract, just copy paste the manuscript, get a summary using for an abstract. Of course, I never use the final version. Like, my final version is not what ChatGPT gave me, but as a starting point. Or summarizing content for project applications, or for dissemination material, non-scientific stuff. It can be quite efficient to save you working time.
Thank you very much, Dr. Phillips. Any else question? Okay. I just copy that you're writing there. Any else question? Okay. I'm sorry. Okay, if not, maybe I need to give you share your where's the wait. I will share the certificate from the university to Dr. Phillips. Okay. Dr. Philip, now the university give appreciation for your essential sharing about how to write manuscript and the scientific writing. This is from Dr. Fatur Rahman M. Pung, the School of Postgraduate. So now the name is Postgraduate School. Before just only graduate school. Now it's different. And now the graduate school is coming back to the faculty. So in here just have a five department. And now with this how the webinar is from Magister Program of Primary Education. Actually also supporting by Sport Science Department and Physical Education, Master of Physical Education. Okay, thank you very much, Dr. Phillips. How you always open your hand and to share with us, and hopefully you can come directly to Indonesia, maybe in a question time, I don't know.
I hope so too. I think we have been very close to it this year, when
Yes.
unfortunately it was not possible because of
Yeah.
the regulations.
Unfortunately, because of COVID issue.
Yeah. But I already saw online that they changed the regulations already, and it would be possible now. So
Alhamdulillah.
next time, I
Maybe
think.
next year. Maybe
Yes.
next year. Yes. Thank you very much, Dr. Phillips. And can we take a picture together before we finish this class? Okay, please open your camera, all student or participant in here. So this is not only master program, also have from physical education program, like Dr. Zahri from doctoral program. Also have Dr. Simbolon joined in here, candidate program for candidate doctoral program. Okay, please open your camera, take a picture 1, 2, 3, cheese. Okay, wait a minute. This is still, and then second slide. Oh, second slide, where is the others? Please open your camera, second slide. Yeah, third slide. Oh, that's right, no one. They're still sleepy
Oh, too bad for them.
because no open the camera. So I'm not believe that they're still in here. Okay, so there is have a Professor Dr. Setiara Hayu Phillips. Do you still remember her?
Mhm.
Professor Tia, do you have any something word to Dr. Phillips? Uh, unmute Prof. Setia. Okay, can okay. Okay, Prof. Trijoko, not in here. So I think it's enough for today. And for all students, you can write the Google form. This is will have a
Hello, Philip.
yeah.
Okay.
Hello.
I'm sorry,
Ah,
I'm in the class.
Hello, hello, nice to see you. And hopefully see you
Okay.
next time, next year in person.
See you next time. Thank you very much for your coming in webinar.
Thank you for having me.
yes. Thank you very much, Philip. And last year we still have a Professor Sugianto, but now he already passed away.
Yeah, I was quite sad when hearing it. He
Yeah, so-
seemed like quite a friendly person, and especially the last time when we saw here, there was this accidental, I don't want to specify it,
yes.
this accidental event where he showed a quite funny reaction, and that was the last pictures I basically saw with him live. Yeah.
Thank you very much. For all students that all everyone already get the Google form. Thank you, Philip, for always supporting us, supporting for Universitas Negeri Semarang to more better every day because you support us also. Okay, thank you. I will close this occasion. Assalamualaikum warahmatullahi wabarakatuh. See you in the good time, in another good time.
Thank you also from my side for everyone's attendance, for showing your interest, for asking interesting questions. And yeah, finish from my side and have a wonderful day.
Okay, thank you.
Bye-bye.
Bye-bye. Bye-bye, Philip.
Bye-bye.
Okay, all of you, jangan lupa untuk Google Form-nya diisi ya.
Iya, Bu.
Nanti akan langsung sertifikatnya ke email Bapak Ibu masing-masing. Dan semoga bisa digunakan untuk kenaikan pangkat. Oke, Saya kira cukup. Astagfirullahaladzim. Ditulis, silakan bisa dituliskan. Terima kasih Pak Sahri. Silakan kalau yang mau download tadi, untuk download ada di link berikut. Sudah saya share. Dan semoga Bapak Ibu semua nanti yang menuliskan manuskrip bisa diterima di jurnal internasional yang bereputasi. Baik Q1, Q2, Q3, Q4, ataupun yang bersinta. Dengan menggunakan rumus yang disampaikan oleh Mr. Phillips. Oke, saya izin live ya. Atau masih di sini dulu sampai jam 11 nggak apa-apa. Sampaikan dulu sampai jam 11. Apabila ada yang kegiatan yang lainnya, juga bisa meninggalkan. Atau apabila ada yang ingin diskusikan, bisa disampaikan di sini. Masih ada? Ini Pak Aidi dari tadi diam aja loh, tak sebut namanya diam aja loh. Kenapa nggak ngomong Pak?
Iya, Bu.
Hah?
Lagi bingung, Bu.
Bingung kenapa Pak?
Terlalu ini, Bu, apa terlalu cepat untuk penjelasan materinya tadi, Bu. Jadi agak telat isinya.
Yang terlalu cepat?
Iya, Bu, apa penjelasan materi yang tadi itu, Bu, Pak Philipnya itu.
Oh ya,
Jadi agak
karena langsung dari natif ya. Jadi memang bahasanya beda dengan bahasa kita. Jadi agak loadingnya lama ya Pak ya.
ya begitulah, Bu.
Ya. Terima kasih juga ada Pak Suwarno ini senior.
Siap Bu Titin.
Ya, terima
Dosen,
kasih. Salam.
sukses hari ini.
Ya, thank you very much for your
Ya.
coming.
Cuma ini perlu masukan kalau bisa ada penerjemah setiap bait itu Bu Titin biar lebih jelas gitu.
Nah, nanti
Soalnya
nggak selesai-selesai Pak.
biasanya bahasa Jawa ini.
Sebenarnya nanti kalau waktu saya di Taiwan gitu, itu sudah pakai ada headsetnya itu langsung diterjemahkan dalam bahasa yang dimau apa, bahasa Indonesia, bahasa Jawa, bahasa
Oh gitu
Rusia,
ya. Bisa
dan
langsung
bahasa
ya berarti.
Inggris bisa. Iya, hanya pakai
Oh,
headset aja.
headset oh gitu ya.
Masalahnya saya nggak punya itu. Mungkin nanti Bapak beli headset yang bisa gitu langsung.
Berarti headsetnya yang aplikasi langsung bahasa Inggris ke bahasa Jawa atau bahasa Indonesia gitu ya?
Ya,
Ya gitu ya ya ya.
langsung
Ya,
dipakaikan bahasa Jawa Klemo gitu ya nggak apa-apa nanti bisa.
ya, biar lebih mantap gitu hasilnya Bu Titin ya.
Iya.
Sukses
Terima
dosen ya.
kasih Pak Suwarno,
Biasa.
semoga juga sukses ya nanti untuk manuskripnya. Jangan lupa nama saya dimasukkan juga kalau nulis.
Oh iya. Siap Bu Titin ya.
Terima kasih. Ini Mbak Indah juga mau bertanya? Mbak Indah
Sebenarnya
tadi diam aja.
iya Bu, tapi tadi takut itu Mr. Philip menjelaskan, tapi malah nanti saya bahasanya belum nyambung, malah bingung. Besok saya tanya Bu Titin langsung saja.
Langsung
Gitu.
tanya Bu Titin aja ya.
Oh, kirain mau tanya langsung ke Philip, tak suruh ke sini gitu ya.
Ya Bu,
Ya, terima kasih Mbak Indah. Masih kurang 5 menit lagi. Ada Bu Zahra tadi. Oh, saya lupa nggak menyebut nama Bu Zahra. Tapi udah masa tadi. Maaf ya Bu Zahra. Lupa.
Aman, Miss Titin.
Ya, gimana Miss? Kira-kira tadi Philips recommended nggak?
Very recommended ya. Biasanya kalau pemikirannya orang Barat kan mereka sistematis ya, Miss. Jadi mereka lebih suka sesuatu yang secara scientifically research-nya itu metodologinya mereka tertata. Nah, itu
Betul.
sebenarnya lebih bagus. Jadi ketika nanti kita menulis atau mengajak anak-anak nulis gitu ya, mereka jadi nggak bingung misalnya urutannya seperti apa. Sudah jelas banget research methodnya gimana. Saya tadi ngikutnya terakhir-terakhir ya, tapi masih nangkep dikit lah tentang beberapa tips-tips yang diberikan sama Philips tadi, terutama tentang metodologinya tadi yang kayaknya sangat bagus banget.
Ya, sangat terarah ya.
Betul, betul.
Runtut banget. Aku suka
Iya,
cara pemikirannya ini. Orang Jerman ya, bagus
itu
pemikirannya.
sebenarnya bisa diadopsi juga, Miss. Jadi akhirnya kita memiliki satu uniform ya, ada satu kesatuan yang membuat research kita itu jadi nggak lompat-lompat gitu. Jadi ada satu kesatuannya. Oh, ini secara runut ini bagusnya memang seperti ini biar nanti kita bisa menghasilkan manuskrip yang serupa sama gitu ya, dan semua orang itu bisa memahami ketika baca. Oh, gini gitu.
Betul. Dan itu tadi juga banyak sekali ada tips-tipsnya agar jangan ada dudan, ada jangan sentence. Makasih ya Bu Zahra. Tadi harusnya Bu Zahra yang ngomong juga ya. Aku lupa. Ini ada Pak Kaprodi Unimus juga nih, saya nggak tak sebut ya. Makasih Pak Kaprodi Unimus. Ikutnya baru aja ya Pak ya.
Dari tadi, Bu.
Jam berapa?
Dari 8:30 agak telat emang. Habis
Oh,
ngajar.
ya berarti telat.
Kangen saya sama Bu Titin.
Kalau telat push up lo ya. Ya,
Sehat, Bu Titin?
Alhamdulillah sehat.
Prof, ding. Prof.
Amin.
Amin. Nah,
Didoakan.
amin toh. Harus selalu saya doakan pokoknya.
Terima kasih.
Amin.
Kurang 3 menit. Oke, terima kasih. Mbak Enggar mau menyampaikan sesuatu? Pak Ahmad, Pak Muarif, Pak Aris,
Boten, Ibu.
Betul.
Sama dengan Pak Edi tadi. Terlalu cepat tuh.
Terlalu cepat karena pakai
Iya,
bahasa Inggris atau pakai
iya.
bahasa Indonesia.
Jadi sempat pakai Google Translate pun malah bingung artinya. Waduh, ruwet.
Tenang aja, sudah saya pakai YouTube kan, nanti bisa dicek ulang-ulang sambil
Iya, iya. Siap,
diulang-ulang didengar.
siap, Bu. Terima kasih.
Tinggal klik YouTube-nya, subscribe, dan jangan lupa like and subscribe.
Komennya gimana, Bu?
Apanya?
Lah komennya kok ketinggalan?
Oh ya, komennya ketinggalan. Jangan lupa komen and subscribe. Gitu ya. Sudah? Kurang. Saya kirimkan juga link YouTube-nya. Silahkan nanti yang tadi ketinggalan pelan katanya terlalu cepat bisa lihat di YouTube. Nanti bisa diulang-ulang sambil kayak dengerin pengajian gitu ya. Pelan-pelan dimengerti. Monggo Pak Suwarno, tadi sudah
Siap.
saya share YouTube-nya.
Ya, saya lihat nanti dari YouTube-nya kan biar lebih jelas nanti Bu
Nggak
Titin
usah
ya.
dilihat, didengerin aja Pak. Didengerin dulu. Sambil
Oh, gitu.
bawa Google Translate gitu.
Ya.
Oke, silahkan. Sudah ditulis semua untuk Google Form-nya. Untuk download materinya sudah di-download semua, Bapak Ibu?
Belum. Ini baru proses nih.
Belum selesai.
Ya, selesai.
Semoga yang kita pelajari semua berkah ya.
Amin.
Amin.
Berkah nanti. Enggak kan. Oke, matur nuwun sangat Bapak Ibu. Semoga Bapak Ibu semua nanti yang belajar dan menulis manuskrip tadi bisa terpublish di jurnal-jurnal yang bereputasi. Dan yang pasti ilmunya diridhoi dan diberkahi oleh Allah SWT.
Amin, amin.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi
Waalaikumsalam.
wabarakatuh. Terima kasih, Bu.
Terima kasih, Bu.
Sama-sama. See you in other occasion. Terima kasih Bu Zara. Assalamualaikum.